Akinin from Jabu Technologies. Over to you.
Hello everybody, this is a big challenge. At 1:45, I imagine everybody's about to fall asleep or hungry. So I will try to make it sweet and energetic. So yesterday we had a very important panel about food, energy, agriculture, water, industry, and a poll was passed to the spectators asking what they thought was the most important of those elements where to invest the money. And the answers came as it was supposed to be, like some thought energy, some thought about agriculture, water. My point of view is that it's all of the above. They're all intricately intertwined. And the speaker that was preceding me had the same opinion. They have to come together. So today, we're going to be correlating water, food, energy, technology, capital, and policy. All these elements, I believe, should go together in order to understand where we're standing today and where we're heading. In the big human context, I would like to give some numbers because I always like to dimension things in a way that they can be digested, because we hear numbers and numbers by themselves really don't mean that much. So I'm going to show you something that is really, really captivating. If all the human beings in the world were put together in a box, 1 by 1 by 2, you might call it a coffin if you want to. It's a small box, and we put them all together stacked in a cube. Incredibly, and I challenge you to do the math, they would occupy a 2.5 kilometer square cube. Now, in the big context of things, the surface of that and the bottom part of that cube is 6.25 square kilometers. And just to give you an idea, Cape Town is 1,460 square kilometers. So 400 of these cubes would fit in this city, occupying the space, the area of the city. And that's all humankind. That's 8.2 billion human beings, including everybody. So this gives us an idea of who we are, what we occupy, and how much harm we do. I'm putting together, as a matter of weight, the whole human race. We weigh 410 million tons, okay? All together, and this is an average of 50 kilograms per human being, including those that are 6 kilograms. This is already exaggerated, but it gives us a very flexible number of 410 million tons. That's all we are. We are eating every year 3,000 million. I'm putting it in those numbers because it's easier to understand. 3,000 million, in order not to mention billions or trillions there. We are eating 3,000 million metric tons of food per year. If you want to do the math, that means that every human being consumes about 300 something kilograms, which is 1/3 of a ton, of a metric ton during the year. That's roughly a little less than 1 kilogram. We use 1,800,000 million metric tons of water, out of which, as it's been said before, 70% is dedicated to agriculture to produce food. And we waste 100 million metric tons of food every year. We only use 50% of the 100 million square kilometers of the habitable space of the earth to produce food. So, in the big context of things, we are a little tiny dot in our universal space in the earth, and we have generated all these numbers. Why I'm bringing these numbers is because the word that comes to your mind when you see these numbers is inefficiency. Inefficiency. Put that in your mindset. Inefficiency. So we're talking about the Sustainable Development Goals of the United Nations, the 17 Sustainable Development Goals. And these development goals have to be achieved by 2030. I have news for you. We're not even close. We're absolutely not close to that. We're not going to get there, not matter what we do. And every day that passes by, we are a little bit farther. This is what they can call a logarithmic approach. The closer you get, the farther it gets. What is happening? We are short $5 to $7 trillion. That's million dollars, just to put it in context, short every year in investment to comply with that. And when we don't do that this year, next year we have another 5 to 7 trillion because they accumulate. And at a certain point, we're going to need $30 trillion invested in 1 year. And even if we have the money, we will not be able to do that. So it becomes a not money problem that today is a money problem. Out of that, Africa requires about $4 trillion of that investment per year. And that gives an opportunity to Africa as a continent of $20 trillion in the next 5 years. And that is one of the greatest opportunities in history for any country or for any continent. And this is happening right under our feet right now. And this could generate 360 million new jobs. Africa is sitting on the biggest opportunity ever. What you ever heard about the golden rush is nothing compared to what we're witnessing today. So here are some actions to take. I want to put some actions that we have to take that are urgently needed. And I'm not planning, I'm not so optimistic as to put the whole layout or the blueprint of what we have to do, but I'm going to give some examples that will call our attention and will bring us into the actions that have to be needed, into talking to our politicians, talking to our planners, talking to our scientists and our investors and bankers. I'm going to give you an example because I like to dimensionally show things they can be understood. On the left graphic, we have 2 bottles of juice. One is 24 grams and the other one is 114 grams. The bottle in the right is processed through what they call retorting. So they bottle the juice in that bottle, sorry for using the same term, and they put it in an autoclave for 20 minutes, and they put tons of water inside. They reach the temperature to 120 degrees. They leave it for 20-25 minutes, and then they throw the water out, they recycle it, they take the bottle. So these bottles are subjected to a very high pressure and a very high temperature. And they need to use a lot of plastic material in order to be able to sustain those critical conditions. On the right-hand side, we have a bottle that was aseptically filled after a UHT, ultra-high temperature treatment. And we have a difference of 90 grams in that bottle, in one technology or in the other. On the right-hand side of our presentation here, we have simple water. I want to call out the attention also to something. Nestle is the biggest food producer company in the world. And their main business is water. And it's growing every day, practically whopping big chunks of the whole operation of the company. Someday, they're going to be like 10% food or 90% water. So when a small processor that is bottling water faces the opportunity of entering that business, he buys a blow molding equipment from China that is $80,000. It's very low technology, and he makes his bottles, and each bottle is 38 grams. Nestle and companies like Nestle use very high technology blow molding equipment that run on the same mechanical and physical principle, but are a lot more sophisticated in controlling the width or the specifications of the plastic that it formed, the bottle. So they can allow the system to have an 18 or even 15 grams bottle. Even the cap is smaller. You see the difference between the red cap and the blue cap. So this bottle of 18 grams could be 50. Now, what this comes to at the bottom line is that the blow molding equipment of a Chinese low quality can be $80,000 and the other one can be $800,000. They do exactly the same. But what is the problem? That the small manufacturer, the small investor cannot afford to pay $800,000, but he can afford to buy more plastic for each bottle and make less profit because he has a lower overall cost. His overhead is very small. So he can afford to do this, but the planet cannot afford to receive billions of bottles that are more than twice the weight of what Nestle or other big companies are doing. On the other hand, the UHT treatment and the aseptic technology for filling, they exist. The technology for making those bottles exists. So what I'm calling out here, and this is the part of the science, the technology, we are investing billions of dollars in research to develop new technologies. So that is a different highway going, I would say, nowhere. While at the same time, we have the capacity and the technology to make these bottles for maybe 2 or 3 times less weight, less plastic, less energy, less waste, less occupation of transportation. Altogether, the problem is that the small investors, the small manufacturers do not have access to the capital. If we were using part of the capital that we're dedicating to research to directly give it to these people who are using the wrong technology, we could be saving billions of tons of material, of increasing the warmth of the earth with the weather problem, and decreasing in critical conditions and astonishing amounts the amount of weight that we have to dispose. So that is one of the things where we need to use policy and policing at the involvement of the financial institution and the governments and the multilateral organizations. Then we have another situation here, rice. Rice is the most consumed cereal in the world. It's the most water demanding crop. And the way traditionally rice has been grown is by flooding. By flooding to eliminate part of the pests that attack rice, by flooding because it's the tradition of how people, the farmers from generation to generation have grown. And rice takes an estimated 800 billion cubic meters of water every year. 40% of that water is really not necessary. That is without entering in biotechnology or entering in super high sci-fi kind of technologies. It's just making some changes to the type of crops that we're developing and the agricultural culture of the people who are producing rice around the world. So this rice cultivation accounts for about 34 to 43% of the global irrigation water use in agriculture. Then we have what I call the global water irresponsibility. I was recently involved with UNIDO, the United Nations Industrial Development Organization, and the people from EIIS, the European Institute for Sustainability, Innovation, and we were discussing about Morocco's production, agricultural production. There is a term that you would like to know if you don't. It's called the WSI, the Water Stress Index. The Water Stress Index qualifies or classifies countries according to the vulnerability they have for the amount of water resources they can dispose of. And there are many countries that have a very high WSI, the Water Stress Index. Morocco is one of these countries, and Morocco is flooding Europe, the European Union, with tomatoes, peppers, eggplants, and many vegetables that are very high water demanding. They don't have a price for water. The government doesn't intervene. They don't care if in 2 years there's not going to be water to drink. And the population is suffering for lack of water, while the agricultural business is flamboyant, exporting these crops. So they're not exporting crops. This is a total mirage or a fantasy. They are exporting water that they do not have. So this is a terrible situation, and it happens with other countries. The rational use of desalinated water. I have several hats in what I do. I'm not a farmer, I'm a consultant. So I have customers in the agricultural part, I have customers in the industrial sector, I have customers in the government sector. And so many times I go to so many factories processing in countries that are using either brackish water or saline water, and I see that they use the reverse osmosis to purify the water to levels that are like for injection. I mean, so they go to 0 ppm of salt or sodium. They don't need that. So when you don't rationally use your system, your technology to produce the water that you need, you are producing a water that requires big amounts of pressure in order to push the water through the reverse osmosis membranes, and then you end up producing a water that you actually don't need, because you're going to use this water, maybe, let's call it the starch industry, or those wet process where corn, maize, wheat, other flours, other seeds are used in a wet process, so they soak this agricultural commodity. So you're using water to soak a grain. Why does that water needs to be to the level of distilled water? It doesn't have to, but they're using it. They have the system and they're struggling to make it. So if you see here, you can see that for generating steam as an ingredient for processing and sanitation and for thermal applications is not for steam. It's like when you're cooling, part of the process in all the factories before refrigeration. So we need specifications that go from 10 parts per million to more than 1,000. But most of the factories where I've been, they have a common standard for the water they're producing from reverse osmosis for all the different applications in the factory. There we're spending billions of kilowatt hours that are not needed in making pressure of this water to make the water that they actually don't need. I want to read this, and I want you to read it. Sustainability should not be a burden for consumers. Technology and capital must join efforts to make sustainable products the election of choice for quality, price, and goodness. Consumers should not pay extra for sustainability, and most of the planet really doesn't care or considers the value of sustainable products. Wallets are the ones that go shopping, not hearts. There's very few people in the world that when they go to the supermarket, and I've seen it today in several products that came to my hand, it says, this bottle was made with recycled plastic. This butter was churned in a solar farm. But at the end of the day, it's not how they made it. It's that it costs 10 cents, $2, 10 rands more. So you're paying this toll because you want to participate in making this a greener or a better planet. But when I talk about you, it's 10,000 people of the 8.2 billion people. So we really need technology, we really need policy, we need governments, but we need policy. I said something yesterday that I recall, it's policy without policy is poetry. There's no way, if they give you a speed limit and they say you cannot go over 120 miles per hour or kilometers per hour, if they don't give you a fine, there is no speed limit. So that's the policy and the policy. Water, this is part of ending my presentation. I'm sorry for all the time, but water is not a local resource. We understand that the air is a local resource. You know, the air in the atmosphere contains 21% oxygen. That, and I live in Bogota, which is 2,700 meters above sea level. There is slightly 1% or 2% less oxygen than in Cape Town. I have cardiac problems living in Bogota. So just imagine that if the whole world would go to 5% less oxygen because we're burning it, because we're not replenishing it, and because there is not a harmonic relation between agriculture, industry, water, technology, and policy. So here is where you see that they're all interrelated. And this problem, it's easy to understand because it's the air that we breathe. It's like communicating vessels. It's the same air here, the same air in Bogota, in New York, and in Rwanda. There is no air with more oxygen in Rwanda or in Switzerland than in Cambodia. That we understand, that we're all clear about, and we talk about global warming. But we're not talking about what's happening with water, which is the reason we're all in this conference room today. Water has to become a global resource that we all have a say, and we all regulate it with policy and policy. Thank you for your attention. If you need a copy of this presentation, that's my email address, and I will take some questions if you have any.